Hello, I'm Marilyn Bruno, CEO of Aequor. It's a pleasure to meet you all today to tell you about how to improve renewable feedstock production for conversion into biofuels and renewable co-products. The demand for feedstocks is rising as the climate crisis is creating a huge demand for biofuels. They are the fastest way to reduce CO2 emissions. The renewable feedstocks include microalgae, oil plants, corn, sugarcane, plant biomass, and anything fermented, including from landfill waste, renewable cooking oil, all sorts of things. But the demand is much higher than the supply. SAFs are growing at sustainable aviation fuels at over 50% year-to-date growth. The second problem is that the feedstock demand for bio-based co-products is also rising. And that's going to be for food, feed, nutraceuticals, fertilizers, sneakers, plastics, all sorts of things. So the biomass supply must double to meet the demand. It's already a very big market, with algae market about $100 billion and cellulosic biomass to about $218 billion. The advantages of algae are many, primarily because right away it captures 300 times more CO2 than a tree. So for carbon capture of all the land plants, nothing can beat algae. It can also grow anywhere without any stress on food supply resources. And here are some of the other advantages. But the problem number 3 is that the feedstock production has challenges that have to be overcome because in general there are low biomass yields. Algae cultivation is challenged by clumping and shutdowns. When the algae clumps, it can't grow. In fermentation of any cellulosic biomass using yeast, there's ethanol intolerance of the yeast. Also, there are contaminants attacking both the algae and the yeast. Plus, there are high operational costs in harvesting those initial feedstocks before they can be fermented. So 3 treatments are needed: anti-clumping, extending the biomass harvest cycles, decontamination, and crop protection. In addition to cleaning the surfaces, because all of the fermentation processes, etc., suffer from something called biofilm, bacterial and fungal contamination. We discovered novel marine microbes in the coral reef. They're remarkable because they are inhibiting the attachment of bad bacteria to these surfaces. So we were able to isolate the chemicals produced by these microbes and have some synthesized chemicals that we're using for our formulations. They're approved in the United States under the Environmental Protection Agency's Toxic Substances Control Act. Some are certified as green, generally regarded as safe, and they're all non-toxic. They're available in ton quantities. So we have formulated custom products for biomass boosting, crop protection, and system cleaners. For example, as validated by the U.S. Department of Energy, we validated that yeast, when it's not attacked by bacteria, can increase the biomass by up to 30% in less time and without the need for antibiotics. This is important because antibiotics are used in fermentation systems to protect the yeast, and those residues of the fermentation are sold as animal feed. So when you hear about antibiotics in animal feed, it's most likely coming from this fermentation process. we can eliminate the need for all antibiotics. In algae, this study was done by the Lawrence Berkeley National Lab. We see a boosting of 40% of the algae biomass in half the time. That is really a wow. Primarily because there's no clumping, you can extend the harvest cycles, and you're using the existing infrastructure, both in the fermentation and in the algae cultivation. You don't need anything new. And in crop protection, when you're cultivating algae in open ponds, which is how you can really achieve commercial scale very fast, 2 of our products protected 2 of the algae strains from the predators. These are fungi amoeba. We can provide you with reports on these. So in the competitive landscape, you're looking at what is used currently, and you see they're using genetically engineered algae and yeast strains that are resistant to the predators or can increase the yields, accelerants, media supplements, biostimulants, and antibiotics and biocides. In addition to mechanical methods to boost biomass production, such as water agitation, bubbles, all sorts of things. So then you have Aequor's 3-in-1 treatment, and you see that it's much less expensive. It's a drop-in, easy-to-use product. And there you have it. So we're able to lower production costs to meet feedstock industry objectives, increase the margins with the existing infrastructure, improve the end-use product stability and adoption, capture billions in stimulus incentives for biofuel production that's being offered by many countries, which of course creates jobs in the renewable sectors, improving everybody's environmental profile and taking a leadership role in the bioeconomy. Now this vision is already being realized. The first algae-powered building was built in Hamburg, Germany in 2013, and there it's not only interesting architecturally, but it's creating all the energy that the building needs. The next picture, you're seeing rooftop algae cultivation in bioreactors, those hanging bags. That's also extremely interesting because anywhere algae can be grown. And as you see in the next picture, that's the Sahara Desert, where a large algae project has been built. You don't need any special water for algae cultivation. Algae just needs CO2, water, and light, sunlight, or light bulb light. It's not picky. It grows in brackish water, salt water, recycled water. As you can tell, we are big fans of algae. I'm going to add some additional considerations here, because biofuels are the big promise and everyone agrees with that. But there's a problem with the biofuel stability, and I mentioned this very briefly earlier. So since biofuel is made out of organic material, water separates out. Right away when water separates out, you're going to have bacterial contamination. And this contamination includes hydrocarbon utilizing microorganisms, which are nicknamed humbugs. The biofilm that these humbugs form attack the surfaces that they're in contact with. Could be engine surfaces, filters, storage tanks, whatever. And they rather rapidly initiate corrosion. in all those components, fuel systems, pipings, fittings, valves, injectors, and again, the storage containers. This is a serious problem where the biofuel is stored. If the biofuel is made and immediately used, this is not a problem. But if you're thinking of biofuels as fossil fuels are currently used, where you have stockpiles of it or reserves, biofuels don't lend themselves very well to that, which is another reason why increasing production fast is very important. The degradation of the biofuel is, of course, also a consideration. And there's odor and black and brown, green, red buildup, and all sorts of things. I mention this because everyone's excited about biofuel production. But as I've tried to show, there are many problems associated with both the production process so that it is profitable and with the end-use product. So much of what we've been doing, since our focus is microbiology, has been to eliminate the humbugs or the other contaminants that are attacking fungi, yeast, and algae, and bacteria in the yeast. So if you'd like to know more about us, do join us. We have as our goal reducing toxic chemicals, improving margins, creating jobs, and contributing to sustainable development goals. And here's our information, my information. Let me know how we can work together. And congratulations on taking on this very important topic and doing something fast to make this climate crisis reverse or at least stop where it's at. Thanks so much. Look forward to working with you.